Hey there, students. It's just me, Mr. Wee. I just want to go with you, start going over through with you a section that I might not be able to cover in class. It's section 9-4, parallel lines and proportional parts. So we've been learning about similarities, similar shapes, and proportionality, and how some of their sides could be proportional to each other. Now we're going to learn that if we create parallel lines within shapes, they actually might result in having parts that are proportional to each other. What is that going to look like? So this is going to be your first theorem that you can put into your own cheat sheet for the exam, but it's going to be the triangle proportionality theorem. So you can read it to yourself. If a line is parallel to one side of a triangle, so if we look here, we have this triangle A to C to D, and it says that if we have a line that is parallel to one side of the triangle, so the side that they're looking at is CD, and the line that is parallel to it is B to E, so this is parallel to CD, okay? And it intersects the two other sides. Well, BE is hitting both the other sides of the triangle. Then it divides the sides into segments of proportional lengths. So it's actually pretty simple. We can actually go by the example here. It just says that if B to E, indeed, a line that intersects both the other sides, not intersects, but hits the other sides, touches the other sides, and is proportional to one side of the actual triangle, which is CD. So BE is parallel to CD. Then let's take a look. AB should be, or AB over BC. So think about it this way. Now, with this BE line, we actually cut this triangle into two proportional parts. So on this length here, AB is going to be actually conform a ratio of to BC. So AB to BC. So this longer side here and the shorter side here, if we make a ratio between the larger side and the smaller side, it is proportional to the same ratio of the other side that the other side can make. A to E and ED. Okay, so it's actually pretty simple. So as long as you create a line that's parallel to it, it divides the triangle in parts that are actually going to be proportional to, or that are actually going to make a ratio to each other, and these ratios are going to be proportional to each other. So in this case, you have AB being proportional to BC, and then AE is now proportional to ED. In fact, I believe you might even be able to say that CD is proportional to BE. But in any case, let's not go there. Let's just say that the ratio between AB and BC is the same as the ratio as AE to ED. So what's this going to look like in a problem? Let's go ahead and take a look at this example here. So go ahead and draw this triangle really quick. I have triangle PQ to R, and then I created and I specify that there's a line that intersects the triangle, or not intersects, but actually touches both sides of the other of this triangle, and it forms a parallel line ST. So ST is going to be parallel to RQ, as indicated right here in the statement. ST is parallel to RQ. And I gave you the side lengths. So 7.5 is PT, TQ is 3, SR is 2.5, as stated right here. The PS is what we don't know. So it's going to be pretty simple. So if we know that you have parallel lines, what it's going to do is going to divide this PR into two proportional parts. PS to SR, so we can say PS is proportional to SR, or makes a ratio PS to SR that is proportional to PT over TQ. Again, because this long segment now is divided into two parts that are going to make a perfect ratio that is proportional to the ratio of the other sides on the left here. So let's actually plug in some values here. PS is what we're solving for, so we don't know what PS is. We don't have a number that we can substitute in there. PQ, or PT, is going to be 7.5. Okay, so that's what we got from the given information above here. And then TQ, we're going to put that over TQ, which is just 3. And then PS is going to go over SR, and then SR we know is 2.5. So you might not be able to recognize this, but PS is just you can look at this as just one big giant variable. In the same way, you can just look at this as being X, or some kind of unknown variable you're solving for. So if you look at this, proportional or proportions, how would you solve for this? Hopefully you would know that you just cross multiply. So you'd have an instance where you have 2.5 times 7.5 is equal to 3 PS. And you look at PS as just one giant variable that you're looking for, not just individual letters P and S, but just this whole chunk right here is just one side length that we're trying to solve for. If you work this on your calculator, you're going to get 18.75 is equal to 3 PS. Okay. And then to solve for just 1 PS, or just the length of just PS, not 3 PSs, not 3 PSs, but just one. You have to divide both sides by 3. And then simply put, PS will be equal to 6.25. Okay? All right. Well, that's going to be an introduction to parallel lines and proportional parts. And we're going to continue on in part 2. Okay. Thank you guys for joining me.